Hey class, Dr. Yeo here again, finishing up chapter 14 in our discussion of um, desert landforms. Last time we talked about aeolian processes and sand dunes, and this time I'm going to change gears a little bit and talk about um, one of the primary sort of landform types that we see in deserts, really common in the American Southwest, and that's kind of why I wanted to um, focus on it, and that is called mesa and scarp terrain. And the term terrain just means what we see with our eyes. Mesa and scarp are two common landforms that we would see in the deserts of the American Southwest, West Texas, um, New Mexico, Arizona, Utah, places like that. So when we talk about a mesa, we are referring to a landform that looks like a table. The word mesa means table in Spanish, and so you have a flat top up on top um, that is less weathered than the material below it. This stuff is less weathered than the material below it because remember, this top rock is in this incidence is what we're going to call or what we would believe to be a cap rock. It's flat. It's not nearly as weathered or eroded as much of the stuff beneath it. And so we would be familiar with this idea of this landform being a mesa. It kind of looks like a table, right? It's flat on top, tall, sits up around the things that are around it. And the reason that it has remained up when other things have eroded and weathered down is because of this cap rock, which is resistant to infiltration, weathering, and erosion. A lot of times when we look at mesa, they will have this flat, nearly vertical wall underneath that we refer to as the scarp or the escarpment. We talked about escarpments when we talked about plate tectonics. An escarpment is just a vertical displacement of uh, of Earth. Now, when we talked about it back then, we were referring to an escarpment as a vertical displacement that happened at a fault um, or a fracture in the bedrock. This isn't necessary. When we refer to scarps in terms of mesa and scarp terrain, we're not necessarily referring to things that happen because of plate tectonics. This more than likely happened due to weathering. When we look at a mesa or when we look at the Grand Canyon, we're seeing layers and layers of sedimentary rock on top of one another. Some of those are going to be harder rocks, stuff that is difficult to weather, and some of it is going to be more eroded, more easily eroded, easily weathered away. And so what happens is the resistant rocks resist erosion, whereas the stuff underneath them erodes away and eventually undermines the resistant rocks. So you'll have overhangs of harder resistant rock, and the stuff underneath it erodes and weathers away. The even though the cap rock may be resistant to weathering and erosion, it is not resistant to gravity. So once the more eroded material underneath it leaves it overhanging too much, gravity will pull that stuff down. And so even though the cap rock is resistant to erosion, it will get smaller and smaller over time. These mesas look like elevated plateaus, right? And so oftentimes they're referred to as stripped plains because they're flat on top. When we look at these mesas, we refer to them as differential weathering because you have weathering happening at different rates with the different rocks that make up the mesa. The cap rock and the more resistant material will weather at a different rate than the material that is more easily eroded, and as such, you get differential weathering in the landform. Mesas generally, what one thing we'll look at here is a mesa versus a butte. versus a pinnacle. They're all sort of similar things, but a mesa is wider than it is tall. Okay, mesas tend to be very wide or very long, but not terribly tall. A butte forms the same way as a mesa. The only difference is that a butte is not wider than it is tall. A butte is about as wide as it is tall. Okay, move that picture up there so you can see it better. So you see how this is a perfect example of a butte because it's just about exactly as tall as it is wide. And then a pinnacle would be something like this, that is taller than it is wide. So this is not very wide at all. This is, but it's very tall. Pinnacles are also called spires, or they are also called monuments because they kind of look like statues. Um, that's all well and good. All those words mean the same things: pinnacles, monuments, and spires. But they are all taller than they all are wide. Again, buttes are as equally wide as they are tall, and mesas are wider. See how long that thing is, than it is, but it's not that tall. Okay. Um, Hoodoos, we've talked about a couple. I've shown you pictures of this um, earlier this semester. Things like hoodoos, which really are just um, pinnacles that form in large numbers in a given place, happen when you have a excuse me, a mesa or a plateau that is being exposed to weathering, and over time uh, these all this different weathering arranges the rock into what's called a fin. It's sort of like a long finger of rock that comes out, and over time the fractures or the joints in that fin wear down, and so you're left with these individual rocks that are standing by themselves, and some of them can be in really crazy shapes, really interesting, and we call those hoodoos. But all three of these happen as a large uplifted um, piece of bedrock, that mesa or that plateau, that big rock that was there slowly weathers away over time, and then can create a butte or a pinnacle or a mesa or a hoodoo. All of those things form as that plateau retreats and comes backwards. A couple other landforms I just want to make sure you see a picture of. Something called a Badlands. We have a national park called Badlands, and Badlands are common. There's lots of badland areas out in West Texas. Badlands happen in areas where there aren't really cap rocks, and so or there haven't been cap rocks for a long time. Maybe there was a long time ago, but you have relatively easily eroded ground. So whenever it rains, the over time the ground has weathered away, and what you're left with is lots and lots of sharp, tiny, small watersheds, and they call this landscape a heavily rilled landscape because you have lots and lots of small streams that are really sharp in nature, and uh, if you've I don't know if you uh, most people don't go to Badlands National Park. It's not a place that has the postcard beauty of Yellowstone or places like that, but it's a really neat place. But the word Badlands came from the pioneers who had to travel through there, and man, oh man, it would be getting lost in a place like that would be an absolute death sentence. It's a bad land because there's no water, and getting through there would have been virtually impossible. But for our purposes, these this type of landscape is formed by lots and lots of erosion of relatively soft material, and leading to lots and lots of rills, and lots of small watersheds, um, which is neat to see because it doesn't rain much there. So it's a very alien sort of landscape. Last landforms I want to show to you are arches and natural bridges. So we have a national park based on arches, which is in Utah, and then a national monument, um, natural bridges, which is also in Utah, but there are arches and natural bridges in lots of places. Arches and natural bridges both form as sedimentary rock weathers, um, and arches and natural bridges can look very similar. The difference is that a bridge, just like a bridge gets you across a river, a natural bridge forms as water flows underneath it and makes its way through a weakness in rock. So natural bridges are formed by water. Arches, on the other hand, are formed by wind. They are formed by precipitation getting into microscopic joints, microscopic openings or joints, or any weakness in a rock, and freezing and thawing, sort of those normal weathering processes that we talked about earlier in the semester. Arches are not formed by running water. Natural bridges are formed by running water. So these are arches here, sort of three arches in one place. This is a natural bridge here, and water is running underneath here that caused this bridge to be formed. Okay, this is a pretty unique meandering stream that formed. This is a place called Horseshoe Bend State Park in Utah, and so even though this is different than the meandering streams that we looked at, the processes of the meandering stream still happen here. This is just in rock, as opposed to, where we looked up at the Souris River, the the bluff that stream was widening into was much easier eroded than this would be. But if the outside of this stream here broke through here and created a pathway through here, that would be a natural bridge, and would imagine that might happen at some point in the future. But natural bridges are formed by water, and arches are formed by more the sort of those basic weathering processes, freezing and thawing, some aeolian processes, and changes in temperatures and things like that. Okay, with that being said, I'm gonna stop. We talked a lot about these things. Make sure to do your reading assignments and for this stuff. And of course, if you have any questions about aeolian processes or desert materials, or excuse me, desert landforms, by all means, let me know, and I'll be happy to make sure you're right on track. Okay. Alrighty. Have a great day.